This is a motor starter. The top portion is called the starting contactor. It's a special purpose relay whose contacts are designed to operate a certain horsepower motor. Just a minute we'll take a look at the nameplate and see exactly what that is for this particular starter. So on the inside of this top section we'll find a relay and contacts. When the relay is energized, the contacts go closed to start the motor. Down below, this section is called the overload section. We have three separate what we call heaters, and we'll take a closer look at these individual heaters and talk about how we size those particular heaters. So if the motor draws more current than what it's rated for a period of time, the overloads will operate to de-energize the coil in the starting contactor and stop the motor. The red lever is actually a push button that allows us to reset the overloads in the event that we do have an overload trip on the motor. On the top portion we can see where the power is brought in. This is L1, L2, and L3 to where the power is brought in. There are also some auxiliary contacts on the side, my holding contacts, and they're labeled 3 and 2 for me. This is also on terminal screw number 3 while bringing the incoming power into the motor starter to initially start operation, energizing the relay and starting the motor. Down below on the bottom, these 3 terminal screws are very important. They're labeled T1, T2, and T3. And from there's nothing else to the motor. Just a straight shot of wire from there on into the motor. To bring power into L1, L2, and L3 on the top will come from some type of disconnect switch, be it a disconnect switch, a fuse disconnect, or a circuit breaker. Let's take a closer look at this nameplate and see what information is available there. This is the nameplate on the motor starter. Here our holding contacts are labeled 2 and 3 as we talked about before. In our incoming power it's labeled L1, L2, and L3, all for the terminal screws that are located up and behind the nameplate. This particular motor starter is a NEMA size, NEMA, National Electrical Manufacturers Association. This is a NEMA size 00 motor starter. Down below it tells us that at 200 or 230 volts it will operate a 60 Hertz 1.5 horsepower motor, which is 1.1 kW. Or if we choose to operate a 460 or 570 volt 75 volt AC motor, it is rated for 2 horsepower or 1.5 kW. The coil down below, this particular coil is rated at 480 volts 60 Hertz, and you can see the terminal connections to the coil right at this point. Let's read our coil and contacts with the multimeter then. I set the meter up to read resistance. I verify the meter operates properly by touching my test leads together, and the meter goes to 0 ohms. And first I'll read the resistance of the coil. So I read from, they'll be labeled A1 and A2, and it is reading 0.707 kilo ohms, which is 770 ohms, or 707 ohms. So we would have to assume that this coil is good then, 707 ohms. The main thing is we didn't get open circuit, indicating that the coil is burned open. Next I can read from the L1 terminal screw located on the back top side and read down to T1, and right now I should get open circuit because the contacts on the inside are open and my meter does read OL. Same is true if I read from L2 to T2, I get open circuit on my meter, or if I read from L3 to T3 I get open circuit on my meter. Now I can manually operate these contacts by hand, so I can go ahead, I'll put one test lead, if I can get it to stay there, and then I'll put so I have one test lead on T1 and I'll put the other test lead on L1 and I get open circuit on my meter. But now I can take a screwdriver, push the button in, and manually close those contacts, and when I do, my meter goes to 0 ohms, indicating that those contacts are functioning properly. And of course I can also check over to, and I could go ahead and I could check the same thing from L2 to T2 and manually operate the contacts and verify they go to 0 ohms, and the same thing from L3 to T3 and verify my meter does in fact go to 0 ohms when I manually operate the contacts. Next thing let's do is let's take a look at the inside of this unit. We'll first look at the starting contactor portion below, then we'll take a look at the overload relay section on the bottom. Connecting the wires that go to the coil, this particular wire that I'm taking off goes down to the overload contacts, so that if the overload contacts were to open up, they would de-energize the coil. The other wire that I'm taking off comes directly from the start push button or pressure switch or whatever control element that we're using in order to energize the starting contactor. Now I'll pull the nameplate off. And we can see the coil on the inside. As I pull the coil out, we'll see that there is a magnetic pole pieces that are attached to the coil. So the coil comes out, and notice these laminated pieces on the bottom of the coil. When I energize the coil of wire, of course that creates a magnetic field around the coil, and the laminated pieces tend to concentrate those magnetic lines of flux. These pieces come in two separate parts. So in other words, when I energize the coil, this bottom piece is pulled up, and when that bottom piece is pulled up by the magnetic field from energizing the coil, that pulls up on this lever. This lever operates the contacts on the inside. So next thing let's do is let's pull this section off, and we'll take a look at the contacts on the inside. So we just have these two screws to remove. And this takes off the block with the movable contacts on it. So again, if we pull this lever up, I said it operates contacts. If we look on the back side, we can see those movable contacts. These contacts could be replaced if we needed to. These look in excellent shape, so there's no need to replace these. The stationary contacts on the inside also look in excellent shape, but we could remove a screw and replace those contacts if we needed to as well. So what's nice about the NEMA starter is, if we had to, we could easily replace the coil, or we could replace both the stationary or the movable contacts if we needed to. Next thing, let's take a look at this overload section down below. We often refer to these as the heaters. These particular heaters are sized for a certain horsepower motor. If we were to take a look at the chart that comes with this motor starter, we would find that based on the full load current on the nameplate of the motor, there's a specific size heater element that we should buy and insert. These particular ones are B0.44, referring to our chart that tells us for a specific full load current on the motor, that's the size we should be using. So let's pull out one of these heater elements and take a look at it. Now there are different types of heater elements that we can have. They can either be bimetallic or solder pot. These particular ones are called solder pots. Notice the full load current that goes to the motor is going to pass right to this heater element, go down to T1 and on out to the motor. Now, wherever current flows, it produces heat. We know that's just a law of physics. So as current flows down to the motor flowing through this heater element, it begins to produce heat. If enough heat is produced based on the full load current of the motor, then solder is melted in this little chamber on the opposite side. When that solder melts, that allows this little wheel to be able to turn. It can't turn right now because the solder is solid. But if I were to melt that solder, I could certainly turn that wheel. When that wheel is allowed to turn, that allows a trip mechanism on the inside of my overload relay to operate. So, when I push the reset down, it resets this little lever, and if for any reason I were to get an overload current to the motor for a period of time, enough current flow to allow the solder to melt, then this little mechanism is allowed to trip, and when it does, that trips the overload contacts. The overload contacts you can actually see operate. They're over here on the side, bottom left-hand side of the motor starter. Current coming out of the motor overload contacts goes back up once again to the coil on the motor starter, and if those contacts open up, that's going to de-energize the coil on my motor starter then. So that is a standard NEMA size 00 motor starter.